Today we are looking at what an imaginary number is. An imaginary number is when you take the square root of, let's say, 4. The square root of 4 is 2. 2 times 2 equals 4. But then when you take the square root of negative 4, what two numbers that are the exact same multiply to negative 4? It's not possible. And that's where that's where imaginary numbers come from. Negative 2 times negative 2 gives you positive 4, and negative 2 times positive 2 gives you a negative 4, but these are not the same number. So neither of those situations work. So this is where imaginary numbers are introduced. So the square root of negative 4 is called 2i. So the imaginary unit I is defined as the square root of negative 1. Square root of negative 1 is I. Again, anytime you take the square root of a negative, that's where you get an imaginary number. So they're written in the form bi, where b is the real part and I is the imaginary part. So let's look at a few examples where you'll see this. Some will pop up when we're solving. You'll also see a radical in the quadratic formula where you might get some imaginary numbers. Because again, certain quadratics you can't solve by factoring. All quadratics you can solve by the quadratic formula. So that's what we're going to get to. We have a whole unit on radicals, but just to show you a few. Square root of negative 9, that's 3i. You want to check if these are perfect squares. Square root of 196 is 14i because of the negative. Number 3, square root of negative 5. Well, that's not a perfect square, so you would just pull the I out front and write it as I radical 5. Number 4, square root of 80. That's not a perfect square, but we can go ahead and pull the I out. We're going to have to do something called the ladder method. You can also use a tree diagram to break down and simplify the radical. Remember, just like you wouldn't leave a fraction as 2/4, you would just say 1/2. Same thing with radicals. You're not going to leave something unsimplified. So using the ladder method, what you do, and we have a whole unit on this, so we'll get back to this as well. You take the number under the radical, and you always start by trying to divide by 2. 80 divided by 2 is 40. 40 divided by 2, 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 2, well, that doesn't work. 5 can only be divided by 5, which is 1. Then we are going to group these, because remember, the square root is two numbers multiplied together to get that perfect root. So here we're going to group by 2's, and any single numbers have to stay out. For every grouping, you can take one of those numbers out front. So I can take out a 2 and a 2 with the I, and then the single numbers have to stay on the inside. The 5 will stay underneath the radical, and you always multiply when there's multiple numbers out front, so that will be 4i radical 5 as the final answer to number 4. Again, we'll look at this ladder method one more time today, and then we'll look at it again next unit. Maybe a few times when we see the quadratic formula as well. So 32 can be divided by 2, which is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2, and 2 divided by 2 is 1. You have to have 2 of one number to pull it out front. That's the definition of a square root. So I can take out a 2 and a 2 and an I, and then left inside the radical is this one single 2. So 4i square root of 2 is the final answer for number 5. And you always multiply the numbers if there are more than one number out front. Or even if there were multiple single numbers, say there was a 3 down here, and we'll look at that, you would multiply that with a single 2 for the inside. A way to check is to type in square root of 32 in the calculator, and then type in 4 radical 2 and make sure the decimals are the same. Alright, let's look at number 7, solving equations. Sometimes when you're solving an equation, you will see imaginary numbers. So just solving the simple equation here, we have x squared equals negative 81. To get rid of this exponent, we want to get x alone. That's what you're doing to solve. You take the square root of both sides. Remember, the radical and the square will cancel out, and you're left with what's underneath, just the x. And then you also have to add a plus minus when you take the square root when you're solving. We talked about that with completing the square. Square root of 81 is 9, and then if you have a negative, you pull an I out front, and that's your final solution. Now be careful, because in the calculator is going to be a little bit more difficult to see these imaginary numbers. If you're trying to like graph this and look at the x-intercepts, this won't show up. Alright, last one, number 10. We're solving, so you subtract over the 13 and you get x squared equals negative 12. Then you take the square root of both sides. You're left with what's underneath. The square root and the square will cancel each other out. Don't forget to add in that plus minus. I'll go ahead and pull the I out front. And now we have to break down the radical. 12 is not a perfect square, so 12 divided by 2 is 6. 6 divided by 2 is 3. 3 cannot be divided by 2, but 3 divided by 3 is 1. Anytime you hit 1, you are done with your ladder. Circle any pairs. One of those numbers goes out front and the single number stays inside. So when we write it, this is how your answer will look. You have the plus and the minus in the front. Then you write it as 2i. Notice the 2 goes in front of the I. And then the single number goes inside the radical. Again, we will see this type of thing when we get to the quadratic formula in a few days. Thank you guys.